the big killer whales, and as well the stationary killer whales. So some of them, the two ecotypes, one of the ecotypes eats mammals, so sea lions and that kind of thing, whereas the other ecotype eats fish. So it's quite interesting, you know, to collect DNA samples and be out on the water every day. You get to work with whales, so I cannot complain about that. And then from there, I worked a little bit further north on Vancouver Island, Fanny Bay Salmonite Enhancement Society, and Coney Island Shellfish Limited. And from there, I got lots of hands-on experience with salmon aquaculture. This was more of a conservation kind of aquaculture than commercial aquaculture because of the 5 types of Pacific salmon in British Columbia, the coho, chum, pink, chinook, and sockeye, all of them are endangered. So these aquaculture projects were specifically just to help replenish the populations. So after we raised them up to fry level, we released them back into the wild to help replenish the natural populations. So it was great hands-on experience, getting my hands dirty. And yeah, like I said, if you enjoy what you do, you'll never work a day in your life. So I've been very fortunate to be able to kind of travel and work as I travel. And this past summer, I was an oyster farmer in Ireland. I worked with 15 men, and it was just me for the whole summer. And I showed up to work sometimes, and my rubber boots were filled with crabs. So I definitely had a change in my sense of humor by the time I left. So yeah, it's been very good, and yeah, good time. All right, so now let's get into it. Nodipecten subnodosus, the lion's paw scallop. So this species is native to Northwest Mexico and has a very high commercial value of 25 to 60 US dollars per kilogram. The cultural importance is very evident, as you can see here on the flag. Right in the center is the lion's paw scallop. So the Pacific coast of Mexico is home to the largest number of fisheries and aquaculture workers in Mexico, with 18,500 in 2025 alone. So there is aquaculture potential, and there is no current aquaculture of this species here. So here's what we're trying to do with this study to kind of gauge the possibility for future aquaculture and the success of it. So there's a large historical wild production of over 300 tons in 2009 with varied levels since. So with this large historical wild production, there's a bit of a history about it, so I'll get into that shortly. But despite its importance, the lion's paw scallop's physiological performance in aquaculture remains poorly understood. So this knowledge gap creates an opportunity for us to learn more and study more so we can help ensure the future vitality for all of Mexico. All right, so as I said, there's a bit of a history of the lion's paw scallop here in the Mexican waters. So as you can see here, this is the production here and the population for the past about 20 years. So as you can see here, production was the highest back in 2009 with 322 tons. But then only 2 years later, it dropped down to 56 tons. And that ended up in the closure of the fishery from 2011 to 2015, which in turn resulted in many jobs lost, 98 vessels, 300 fishermen, 1,200 dependents, and 50 million pesos annually being lost from the Mexican economy. So this in itself, the overexploitation in terms of mass mortality, diseases, and many factors that play, changes in environmental conditions, pollution, etc. This all resulted in the closure of the fishery for 4 years, which meant a very hard time in the economy, and it kind of gave us more of an incentive and more of a reason to try and learn more about the lion's paw scallop so we can ensure its future vitality and flourishing. So the biological and ecological background. So this is a benthic pectinated species, which means that it lives on the bottom, generally speaking. So this offers cooler temperatures for the scallop, predator avoidance, and as well food availability from generally organic matter that settles down. So the growth potential. When you're trying to find a species to cultivate in an aquaculture setting, there's green boxes that you kind of want to tick. So at the end of the day, most of the time, the companies that are doing it on a commercial basis are in it for the money. So you want to make sure that you have rapid growth. You want to make sure that you have a large size and high market value. And the lion's paw scallop ticks all of those boxes. So with the shell increasing by 0.22 to 0.38 millimeters per day and a growth cycle of 18 to 22 months, there is also a maximal muscle weight of over 55 grams in aquaculture scallops. So the juvenile development There's over 28 centimeters of shell length by the time it's fully grown, and 200 grams in total wet weight, which is very good for an aquacultured species. There is, however, like most species, a sensitivity to environmental variability, with temperature limits ideally being between 12 to 28 degrees Celsius, and after 30 degrees Celsius being more vulnerable to mortality. The optimal temperature is about 22 degrees Celsius, so nice and warm. And they're often found in a lagoon coastal type habitat, and this offers a dynamic, shallow, and high productivity ecosystem with highlight transparency, which is good for vegetation. So, the problem. There is currently no integrative ecophysiological evaluation that has been conducted. This means we have a central knowledge gap. Currently unknown for the lion's paw scallop juveniles is tissue energy allocation patterns during early stages, seasonal tissue coverage dynamics, endogenous energy management, early histopathological alterations, oxidative stress responses, influence of vertical position, surface versus the bottom, and environmental conditions of temperature in degrees Celsius and chlorophyll A concentrations, which is our proxy for food availability. If you haven't seen it, I recommend you go down to the Malacon. It's quite cute at sunset. The sun comes through and it's really lovely, so take a wander down there at sunset sometime. So, early life stage physiology. Early juvenile stage is a critical transition period. The energy allocation determines survival and growth during adulthood. Environmental variability, like I mentioned, in terms of temperature and chlorophyll A, influences stress levels, metabolism, reproduction, and overall organism well-being. So in humans, for example, and fish as well, usually through blood samples, you can identify an elevated cortisol level, which is an indicator of stress response. But in bivalves, we usually look for melanization, mucus secretion, necrosis, or inflammation to identify this. So again, a few things that you want to tick the boxes for in an aquaculture species is you want physiological plasticity to determine aquaculture success, because you want a species that is adaptable and resilient. So this is also what we're looking for in the lion's paw scallop, to be able to ensure that with the fluctuating environmental conditions that we can't really control, we want to make sure that there will be a future for them in this sector. So this is kind of highlights the importance to learn and understand more about this critical life stage. So just everybody has an idea, as I was talking about melanization as an indicator of stress. As you can see here, this is all melanized tissue. So healthy tissue would be more of the regular light color up here, but as you can see all around here, it's melanized tissue. And this is an indicator of stress, and it could be for any number of reasons. Could be temperature variations, anything like that. So yes. So justification. By evaluating tissue condition, endogenous energy management, and possible oxidative damage across two different growth systems and environmental variability, this study will provide a scientific basis for optimizing aquaculture technology and determine if floating surface culture can be adapted for this benthic species. So the study site for this project that we have right now is Laguna Ojo de Liebre in Baja California Sur, Mexico. So as you can see, we're down here in La Paz, and give or take, it's about 800 kilometers up here to the lagoon. And as you can see, it's kind of in a protected inlet, which means that it's more safe from currents and that kind of thing. So it creates an ideal kind of location for shellfish cultivation, and yeah, an ideal environment for scallop for aquaculture as well. And the depth there is between 4 to 5 meters in the lagoon. Just out of curiosity, how many people have been there before? Laguna Ojo de Liebre? Any hands? Oh, yeah, we got one here. Okay, another one there. Nice, nice. Nobody else? I recommend. Have a road trip. Go and see. So, juvenile lion's paw scallops cultured in surface systems exhibit different morphophysiological condition, energy allocation patterns, and oxidative stress levels compared to individuals cultured at the bottom due to contrasting environmental conditions an ecological mismatch with their natural benthic lifestyle. When you think about it, we're kind of taking a species that is used to being in one part of the water and we're moving it to another. So this is kind of all, it makes sense when you think about it because we're moving something from its natural position to another spot. So if you connect the dots, it kind of all makes sense like that. So, objectives. We're hoping to evaluate over an annual cycle the morphophysiological condition, endogenous energy management, and oxidative damage in juvenile line spot scallops cultured in surface and bottom throat systems to analyze the influence of environmental variability in Laguna Ojo de Liebre. Our specific objectives for this project will be to quantify tissue coverage areas using digital histological image analysis, to estimate lipid and carbohydrate storage, as well as oxidative aging pigment, such as lipofuscins, accumulating in the different tissues of the scallop using specific histochemical staining, and to compare the ecophysiological performance of the scallops between surface and bottom culture systems, and consider the difference of thermic and food variability in terms of chlorophyll A variations. So just to explain this one a little bit. So when we have our little scallops, we decalcify them, we take the tissue and we put them into the little molds here and we make keratin blocks out of them. So that's what I'm doing right now. And here in my tweezers, I've got a little piece of scallop tissue. It's gonna go into the mold, we're gonna cover it in keratin wax. And then you end up with the blocks that look like this. So yeah. So environmental monitoring. So we're going to be using satellite image analysis for this. And in this study, we're going to be focusing on sea surface temperature, chlorophyll A concentration, which I mentioned is the proxy for food availability. And we're going to be doing monthly environmental variability monitoring in Laguna Ojo de Liebre. So as you can see here, this is a satellite image of Laguna Ojo de Liebre. And you can learn a lot of information just from satellite images. As you can kind of tell the symmetry, the depth of the waters. You can also tell a bit of the mixology and that kind of thing. So it's very helpful. So this is an important reason to integrate environmental data into physical interpretation. And then on to environmental characterization. Laguna Ojo de Liebre is located at 27 degrees 45 minutes north and 114 degrees 05 minutes west. And as you can see, the extraction of environmental variability data from satellite-derived images is very useful as well. And with this, we can do temperature as well as chlorophyll A concentrations. Luckily, because Laguna Ojo de Liebre is quite shallow, all things considered, we're able to do this for both the top and the bottom as well. Generally speaking, between 20 and 30 meters is kind of the cutoff to be able to get this data from satellite. And because we're only working with 4 to 5 meters, it's very good, very buenos. So spatial resolution of 1 kilometer squared we'll be using, and temporal resolution daily during 1 year from the site where the scallops were cultivated. So as you can see here, La Paz should be about here in this region. So we have about on a lower scale, 0.70 to 0.50 milligrams per cubic meter compared to the Pacific coast. So now on to stat production. So just a little overview for everybody if you're not familiar. Basically, scallops are simultaneous hermaphrodites. So this means that they possess both female and male reproductive organs, or gonads as we call them. They are broadcast spawners, which means they release egg and sperm into the water column for fertilization. And this is usually triggered in the wild by water temperature changes in the spring and the fall. But in captivity or in a hatchery setting, it can also be induced hormonally or through changes in temperature as well. So as you can see here, you start with the little eggs and then you move over to the larvae as they grow up and up and up. And then eventually you get over to the juveniles. So when we're introducing them into the water, we're introducing them at this stage about 3 millimeters, so about 4 months old. And then we move on to their adult phase. So the larval production for this project has been done at a hatchery here at Sibnor. So all of our larvae was produced here, and then they are there for the settlement and early juvenile growth, and we transfer them to the field as juveniles for grow-outs, and they're roughly 3 millimeters when we bring them up to the field. So unfortunately, there's still a lot of post-larval and early juvenile physiological performance, which is largely undocumented. So we're hoping to kind of bridge those gaps in this presentation. So this is kind of just an overview for everybody, so you can kind of see what we're looking at in the sample and what it looks like. So the key question we're trying to answer is, can a surface culture technology designed for oysters be physiologically suitable for benthic scallop species? So in this study, we've had an adaptation of floating bags used for the Pacific oyster, or Crassitria gigas. So these are made of high-density polyethylene and are 1 millimeter squared, fabricated specifically, as I said, for this study. So here you can see the bags that have been kind of turned and made into more of a cone-like shape. So we have the line cross scallops at about 3 millimeters that are put into them. And then there is a rope on the surface of the water, and these cones are attached on, and they just float there. They float there, and they grow. And then for the other sampling sites, we have the bottom here, the bottom boxes, where the 3 millimeter little juveniles are also put into here. So it's about 4 to 5 meters depth, like I said, and a sampling of 30 individuals per month per condition is what we're doing at the moment. So yes, rope and vertical surface suspension for these, and for this at the bottom, according to the species ecology. So on to biometry and histological analysis. So the first thing we do is we record shell length, total wet weight, and monthly growth monitoring. We then move on to the histological analysis, which includes tissue fixation and processing, sectioning and staining, image analysis software to quantify and estimate the tissue coverage area. The morphophysiological condition is what we're looking for, and we do this through estimating the tissue coverage area. And specifically what we're looking for is the adductor muscle, the digestive gland, the stomach, the mantle, and the gonad. After we've done this, we're moving on to the histochemical staining, where we use carbofusel techniques for lipofuscin staining. From there, we also use PAS Alsatian blue to highlight carbohydrates. From there, we use Sudan black to highlight lipids. And from there, we do a quantification of stain area coverage. So the quantification of stain area coverage will help us indicate oxidative damage and lipofuscin detection, and tissue-specific accumulation pattern is we can attribute to the stains. And then onto the statistical analysis, we'll be using a two-way ANOVA, and the two variables we'll be highlighting here are the culture systems by time, and we will be using post-hoc comparisons in correlation with environmental variables. We will also be doing a multivariate analysis as a PCA or GAMS. And then we'll be determining a significance level between the two data sets. And between the two data sets, if the p-value is less than 0.05, so 5%, it'll be determined that the difference between the two data sets is statistically significant. Just to kind of break down the photos. So as I said earlier, we have to decalcify the shells once we collect them. So this here is after they've been decalcified for 3 or 4 days in a solution. So you're able to separate the tissue from the shell. So this is what I'm doing here. So the shell has been separated. So this is just shell here, and the tissue's in there. And then this goes back a couple slides ago where I showed you. That goes back over to here. Where we cover it in paraffin wax. So we put it into the mold, we cover it with paraffin wax, and then it hardens into this. And then a very fine cutter is used by Uvalia, and we make slides out of that. And then with the slides, we're able to scan them, and then we're able to upload them to image software, and then we can highlight the different organs or tissues that we're looking for. So the adductor muscle, stomach, digestive gland, and the mantle. And then from there, we do the histochemical staining. So as you can see, there's a lot of different bottles as you go down the line. So it really is put slides from one to the other, to the other, to the other. So it really is quite a process. It's a fun process. And yeah, it's just looking under the microscope at a sample. So to break it down more for the histological image analysis, so as I said, we have the slides that we make from the blocks. And then As you can see, we have the internal organs here. So the adductor muscle, the mantle, stomach, digestive gland. And then using the software, we're able to highlight everything that we're looking for, the organs or tissue of interest, and then we're able to quantify the area mass. And then this is what we'll use to compare between the two data sets to see the difference in growth and the growth patterns, and as well for the difference in lipids and carbohydrate composition. So at the end, everything comes down to performance. And that's what we're looking for. In an aquaculture setting, like I said, you want to maximize profit, but you also want to maximize performance. You want your species to be fast growing, to be large growing, to be healthy growing. You want the quality scallop. So at the end of the day, it all comes down to performance, but there's many external factors that impact performance. So you have the environment, which will ultimately impact your performance, and the water temperatures. You have the energy intake, and which will impact performance. The energy allocation, how the energy intake is used and how the energy is used. You have the tissue condition, which correlates to the oxidative damage. And then the environment also impacts the oxidative damage. So at the end of the day, everything comes down to performance and everything is kind of correlated. So it's important to consider all of these things. And I would like to thank SIGNOR and the postgraduate program Human Resources Training for having me here. I'd like to thank my supervisors, Dr. Corona and Dr. Ricotta. I'd like to thank Dr. Rodriguez and Ms. Eulalia for kind of taking me under their wings and teaching me the ropes. And the histology laboratory at SIGNOR for the support and interpretation of the results. The Aquaculture Society of Laguna Ojo de Liebre, Baja California Sur. I'd like to thank Dr. Guzman, Dr. Crafty, Dr. Miguel Tripp, Dr. Ramirez, and Dr. Martinez for help with fat production, annual sampling, and environmental monitoring. And I'd like to thank you all for joining me today for my seminar. My email is here. If you have any very, very, very specific questions, feel free to send me an email. I'll get back to you. Otherwise, the floor is open for questions now.
Yeah, thank you very much, Cora, for your interesting presentation. Yeah. So there's any question for Cora?
Please, does any good scallop recipe?
Well, what I'd suggest first is you crack open a bottle of maybe muscadet, a nice dry white wine, pour yourself a bottle of wine, or a glass of wine, or a bottle, whatever you feel like. And what I like to do is I usually like to sear my scallops with lemon and garlic and some white wine. So, and a little bit of black pepper and parsley if you feel like it. So yeah, something simple but tasty. Yes.
Is there a negative or positive environmental impact to farming scallops?
It's actually quite positive. So I know like where we come from in Canada is very stigmatized generally aquaculture, especially salmon aquaculture as they're farming Atlantic salmon in the Pacific right now. But shellfish aquaculture is quite good for the environment as shellfish, so oysters and scallops are both filter feeders. So that means that they improve the water quality. So it's quite good, and at the end of the day, they're helping us improve our water quality. And there's a lot of places where actually they introduce oyster cultivation to try and improve the condition of the water. So yes, it's a good all over.
Do you have any location prospects that would be good for growing them in the future?
We think so. I'll move back to the map so I can show you. So we're looking at specifically lagoons and kind of sheltered areas on the coast. So this is our study site because, like I said, it is kind of protected because you don't want open water because then the turbidity and the currents are not kind of ideal. You kind of want more of a sheltered, protected kind of area. So as I said, the lagoon is here. And then if you also look up here, it's kind of a protected inlet over by Isla Magdalena, kind of in the Santo Domingo Lagoon area. So this would also be a good hotspot. This is where they cultivate oysters right now. So it could be a potential for the future as well. So there's lots of good spots up the coast of Baja California Sur. It's kind of all just about finding somewhere where the depth isn't too deep, and also where there's kind of a protected shore.
Can you introduce them to other countries, or are we just looking at Mexico right now?
We're just looking at Mexico right now, but yes, you can find them all throughout the Pacific. Yes,
And those farms that had been closed down,
yes.
have any been reopened?
So they weren't actually farms that were closed down, so there is no commercial aquaculture of the Pacific or the lion's paw scallop right now. It was the fishery that closed down. So yeah, it was just the commercial fishery that, because it dropped from 322 tons, I want to say, down to 56. That was like an indicator that, okay, we need to stop, let the population bounce back a little bit before it's too late. So yeah.
Somebody else? Students?
Yes.
Désolée, moi, je ne suis pas parfait, mais j'ai un petit commentaire.
Si.
Je pense que tu perds beaucoup d'espace dans ton fond d'écran. Et il y a beaucoup de lettres, et ce sont des petites lettres.
Oui.
Et aussi, il y a des éléments de l'image, tu as aussi des petites scripts. Et tu peux améliorer les photos et aussi signaler sur les photos pour les personnes qui vont et qui sont en ligne.
Si.
Parce que tu demandes qu'est-ce qui se passe, les personnes là-bas, ils ne peuvent même pas voir.
Oui, désolé.
Il y a aussi je ne me souviens pas de l'explication, je pense que c'est dans la troisième image, qui utilise les gens. Et les gens ici, les contrastes avec les couleurs des lettres, je ne peux pas voir le texte.
Ok, désolé. Merci.
Merci pour votre
Ok.
Sí. ¿Alguien más? Somebody else? Online, let me check if there's any question. No?
Yeah. What do you think it is necessary to evaluate the surface culture?
It's
Or why not? Why
So-
yes and why not?
so one of the reasons right now that we're trying to, it is a benthic species, as I mentioned,
Yes.
so naturally are found at the bottom, but we're trying to introduce the top to try and avoid parasites, sponges, and that kind of thing, because that was a large reason for the collapse of the fishery for that period of time. So we're trying to come up with different solutions to try and guarantee the future flourishing of the species and try and mitigate the impacts of any parasites or any sponges or anything that could cause more detriment to it.
Okay, thanks.
Yeah, Alexander? I don't know. Answer. So, yep. ¿Alguien más? Jose, please.
Thank you so much, Cora, for this wonderful presentation. I'm so impressed by all the academic and professional background that you possess at this early age of you. I mean, how old are you?
25, yeah. No
yeah,
rest for the wicked.
I mean, that's impressive. Thank you so much as well for all the wonderful job you are doing with us in the lab. I'm very happy with your attitude, your hard work, your interest for projects, for the confidence that you have on both of us to co-direct your research work. So thank you very much.
Thanks for having me.
No, it's a pleasure. And yeah, I think I mean, you are still working on the sample analysis, data processing, but at the end, I think we are going to get really interesting data to get some high quality academic products. So I'm really happy with that, with the future results of your internship with us. And we are going to keep working.
Oh yes,
Yeah.
definitely.
Merci.
Merci beaucoup. Thank you all for being here today, and I think that concludes my presentation.
Yes, if there isn't any other question, you can conclude. No? Well, vamos a dar un aplauso a Cora.